Good afternoon, class. We are looking at pre-calculus practice test number 3, module 3, covering chapters 5, 6, 7, and section 6.3, inverse trigonometric functions, chapter 7, trigonometric equations, and identities. We want to find the exact value of the expression and justify no calculator, sine 50, cosine 10, plus cosine 50 sine 10. We should recognize this as sine of alpha plus beta, which is sine of alpha cosine beta plus cosine alpha sine beta. Therefore, the result is sine of 50 plus 10. And 50 plus 10 is 60 degrees. 60 degrees is a common arc. Sine of 60 degrees is square root of 3 over 2. Sine of 165 degrees. We can cut this into two common arcs, 120 degrees and 45 degrees. And now we use this one, sine of alpha plus beta. So sine of 120 cosine of 45 plus cosine of 120 sine of 45. Now, sine is positive in the first and second quadrant. And 120, first of all, the reference arc for 120 is 60 degrees, which means it's the same as sine of 60 degrees. In the second quadrant is positive, so it's square root of 3 over 2. Cosine of 45 and sine of 45, both of them are square root of 2 over 2. Cosine of 120, the reference arc is 60, is the same as cosine of 60, but in the second quadrant, cosine is negative. So cosine of 60 is positive 1/2. Cosine of 120 must be negative 1/2. So we write square root of 3 over 2 for this one, square root of 2 over 2 for cosine of 45, negative 1/2 square root of 2 over 2. The product of these two is square root of 6. The product of these two is minus square root of 2, and the denominator is 4 for both cases. Prove the identities. Part A. ln of the absolute value of secant x plus tan x plus ln of absolute value of secant x minus tan x equals 0. Well, we start from one side, and in this case, the left-hand side is more complicated. And for logarithmic properties, the product rule says ln of xy is ln x plus ln y. If we go from left to right, or if we go from right to left, then we have ln of x times y, ln of this piece times this piece. Secant plus tan times secant minus tan. The product of the two is secant squared minus tan squared. So we are using a plus b, a minus b, which is a squared minus b squared. So ln of secant squared minus tan squared. Now, what is secant squared minus tan squared? Take a look at this one. If I move the tan squared and make it negative on the right side, becomes 1. So secant squared minus tan squared is 1, and ln 1, we should know it's equal to 0. All right, we're going to continue, everybody. Sine theta plus cosine theta quantity squared plus sine theta minus cosine theta quantity squared equals 2. We start obviously with the most complicated side, which is the left-hand side. To square this, we're going to use a plus b squared, a squared plus 2ab plus b squared, and this one a minus b squared. So this one is sine squared plus 2 sine theta plus cosine theta. This is sine squared minus 2 sine theta cosine theta plus cosine squared theta. So let's square The first piece, as I mentioned, sine squared plus 2 sine cosine theta plus cosine squared, plus, let's square the second piece, sine squared minus 2 sine theta cosine theta plus cosine squared theta. These two cancel each other. We have two of these. And two of this. So 2 times sine squared plus cosine squared, which is 1. 2 times 1 becomes 2. Solve the equation 2 cosine theta minus square root of 3 equal to 0. And theta is in the first complete revolution from 0 to 2 pi. And we want to find the general solutions also. Of course, we are going to move this to the right side, becomes positive and divided by 2. So cosine theta is square root of 3 over 2. It's a common arc, common angle. Theta is pi over 6. Cosine of pi over 6 square root of 3 over 2. Cosine is positive in the first and the fourth quadrant. In the first quadrant, pi over 6. In the fourth quadrant, 2 pi minus pi over 6. So we get 11 pi over 6. As far as general solution, just add 2k pi or 2n pi, okay? Solve the equation 2 cosine squared minus cosine theta minus 1 equal to 0. Again, you could use substitution by letting cosine theta be x, in which case you have 2x squared minus x minus 1 equal to 0, or just factor it the way it is. In any event, this one is 2x and x because this number is a prime number. Since this is -1, one of them is 1, one of them is -1. Which one is which? You have to come up with the middle term. So if we choose +1 here, this gives us x. -1 here, this gives us -2x. And the sum is equal to -x. So that, folks, that means 2 cosine theta plus 1 times cosine theta minus 1. That's the meaning of it. So either this one is 0 or this one is 0. This means cosine theta is -1/2. This means it's +1. -1/2. I want to again tell you how to solve when it's negative in the following manner. So when you have a case like that, go with the reference arc cosine theta equals 1/2 and theta is pi over 3. This is your reference arc, everybody. Now you want this to be negative. Just figure out which quadrant gives you a negative cosine. Cosine is negative in the second and third quadrant. In the second quadrant, pi minus theta, that means pi minus pi over 3, 2 pi over 3. In this case, the reference arc is theta minus pi, so add pi to reference arc. Pi and pi over 3, it's 4 pi over 3, and cosine theta equals 1 is equal to 0. So those are the three answers. I hope everybody's okay with that. A quick recap for this question. When you have a negative, go with the positive to figure out the reference arc. And then figure out which quadrant cosine, in this case cosine, the trigonometric function is negative, which is second and the third quadrant. So in this case, theta prime is pi minus theta, which makes theta is pi minus theta prime. By the way, maybe I should write this also. So this means theta is pi minus theta prime. And this means theta is pi plus theta prime. Okay, that's how we get these two. Find the exact value of the expression and justify your answer. 1 minus cosine squared 20 minus cosine squared 70. First and foremost, let's remind everybody of the following. This is 1 minus cosine squared 20, and therefore it's the same as sine squared 20, because sine squared plus cosine squared equals 1. Then complementary angles, when they add up to 90 degrees, so they are called complementary angles or co-functions, okay? Complementary angles are co-functions or complementary angles are equal. Okay, so this is theta, this is 90 minus theta. That means these two add up to 90 degrees. Okay, if A and B are complementary, that means the sum is 90, then sine of A is cosine of B, tan of A is cotangent B, and so forth. So sine of power 2 minus alpha is cosine of alpha. Cosine of power 2 minus alpha is sine alpha. Tan of power 2 minus alpha is cotangent alpha. Cotangent of power 2 minus alpha is tan alpha. Those angles are tangent and cotangent are co-functions, sine and cosine, secant and cosecant. So having said that, we go back to this. So sine squared of 20, you can keep this and change this to, this is the same as sine squared of 20. Because cosine of 70 is sine of 90 minus 70. They cancel each other, we get 0. Cosine 70 cosine 20 minus sine 70 sine 20, and we should recognize this as cosine of alpha plus beta, which is cosine of alpha cosine beta minus sine alpha sine beta. So cosine of 70 plus 20. That means cosine of 90, which is 0. Tan of 20 plus tan of 25 over 1 minus tan 20 tan 25. I hope you recognize this as tan of alpha plus beta, which has the formula tan alpha plus tan beta over 1 minus tan alpha tan beta. So tan of alpha plus beta, tan of 20 plus 25. That means tan of 45 degrees. And we should know tan of 45 degrees is 1. We're going to move on. We want to find the exact value of sine of cosine inverse of 1/2 plus sine inverse of 3/5. First thing first, these are inverse functions. That means cosine inverse of 1/2 is an angle. You can let it be alpha, beta, gamma, x, y, z, you choose. So let's go with alpha and beta. And if so, we are looking at sine of alpha plus beta. And sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Which means now we want to go back here, write each one and figure out what the rest are. For example, this one, cosine inverse of 1/2 equals alpha, means cosine of alpha must be 1/2. And because we are dealing with the inverse function and cosine is in the first and the second quadrant positive always for all inverse functions, puts us in the first quadrant, always. What about this guy? Sine inverse of 3/5 beta, by definition, means sine of beta must be 3/5. And again, this is the first quadrant. Sine is in the fourth and the first quadrant, positive. Any of the inverse functions, trigonometric functions, is positive, it means the first quadrant. And so now that we have that, we're going to use the Pythagorean identity sine squared plus cosine squared to get to the other one. For example, in this case, we have cosine. We're going to get to sine. In this case, we have sine. We're going to get to cosine. Okay, so sine theta is plus minus the square root of 1 minus cosine squared. However, we are going to go with a positive. Why is that? In both cases, we are in the first quadrant. Both cases are positive. So for alpha, we're going to say sine alpha is plus minus the square root of 1 minus cosine squared of alpha. That means 1/4. 1 minus 1/2 squared is 1/4. This is 3/4, and 3 remains. 4 comes out as 2. Same thing happens here. Cosine use a different color actually. Cosine is plus minus the square root of 1 minus sine squared, but we're going to use plus because we're in the first quadrant. So cosine beta is the square root of 1 minus. Now raise this to the power of 2, you get 9/25. As you know, this is 25/25 minus 9 is 16/25, which comes out as 4/5. So let's write the summary. Sine alpha is square root of 3/2. Cosine of alpha is 1/2. Sine beta is 3/5. Cosine is 4/5. Plug it in here. In both cases, the denominator is 10. This is 4 square root of 3 plus 3. And that's an exact answer. Establish identities. Tan of theta plus cosine theta over 1 plus sine theta is secant theta. We start with the more complicated side, the left-hand side. Tan theta plus cosine theta over 1 plus sine theta. And clearly, the best course of action would be to change the tan theta to sine over cosine. We take a common denominator, which is the product of these two. So cosine theta times 1 plus sine theta is the common denominator. Then this is sine times 1 plus sine theta. This is cosine times cosine theta. When you multiply these two, you get sine theta plus sine squared. When you multiply these two, you get cosine squared. In other words, LCD, the least common denominator, and we should have no problem with adding fractions. These two become 1. So we have in the numerator sine theta plus 1, which is the same as 1 plus sine theta. They cancel each other. So the numerator is 1 over, well, the numerator is only 1. So 1 over cosine theta, which is secant theta. All right, sine of 3 theta over sine theta minus cosine of 3 theta over cosine theta equals 2. Again, start with one side. Which one? The left-hand side. Why? It's more complicated. Take a common denominator. The common denominator would be the product of these two pieces, sine theta, cosine theta. So LCD, sine theta, cosine theta. So this is sine 3 theta times cosine theta minus cosine 3 theta times sine theta. So let's see what we notice. The numerator, think of it as sine alpha cosine beta minus cosine alpha sine beta. So sine of alpha plus beta. That's the numerator. So sine of 3 theta minus theta. Okay, sine of alpha minus beta. That's the numerator. Denominator, remember 2 sine alpha cosine alpha is sine of 2 alpha. So this is half of that. So the numerator is sine of 3 theta minus theta, according to this one. If that is the case, that means the top is sine of 2 theta. What about the bottom? The bottom is 1/2 of 2 sine theta cosine theta, which is also sine 2 theta. So the top is sine 2 theta, the bottom is half of that. These two cancel each other. We get 1 over 1/2, which is 2. 1 over 1/2, which is 2. We're going to continue establishing identities, and we have 1 minus sine squared over 1 minus cosine theta equals negative cosine theta. We start from one side, starting with the left-hand side. We take a couple of different ways to handle it. One of them is LCD, okay? One of them is to notice we can factor this. Let me just write the numerator. 1 squared minus cosine squared, which is a squared minus b squared, which is a minus ba plus b. Okay, so that's what we do. Let me use a different color. These two cancel each other, so you get 1 minus. The numerator is only 1 plus cosine theta. So you get 1 minus cosine theta, and that's negative cosine theta Newton. This is if you wanted to use the factoring. You could also use LCD. So right here, take the LCD, which is 1 minus cosine theta, which means this becomes 1 minus cosine theta over 1 minus cosine theta. So 1 times 1 minus cosine theta is 1 minus cosine theta, minus 1 plus cosine squared. In other words, this negative changes the sign of the numerator completely. So obviously 1 and negative 1 cancel each other. Then from the top, I can take the negative cosine theta as a common factor out. I get 1 minus cosine theta. These two cancel each other. and we end up with negative cosine theta. Again, I have no idea which one is faster and easier. I think they're pretty much the same. You decide. They're, I think, pretty straightforward, both of them. Sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta is secant theta cosecant theta. We start from one side, for example, the left-hand side, and we are going to take the LCD. That means we're going to raise the fraction for this one by cosine theta over cosine theta, this one by sine theta over sine. This means we are taking a common denominator, everybody. The common denominator is sine theta times cosine theta. In any order you want to write it, makes no difference. But on purpose, I'm going to write cosine theta times sine theta. You'll see in a moment why I do that. And so having said that, this becomes sine theta cosine theta. This becomes cosine squared. Minus, this becomes cosine theta sine theta or sine theta cosine theta. Minus and minus becomes plus sine squared. So I'm assuming no one has any problem adding the two fractions with a common LCD. So what happens? These two cancel each other. Cosine squared and sine squared, they add up to 1. We're going to cut this into two fractions, 1 over cosine, 1 over sine. Because 1 over cosine is secant theta, 1 over sine theta is cosecant theta. That's why we cut it in two fractions in this format, everybody. Establish the identity. Sine of 4 theta is cosine theta times 4 sine theta minus 8 sine cube theta. On purpose, I want to do this two different ways. Okay, I can start from the left or the right hand side. Okay, so let's start with the left hand side. Perhaps using the right hand side is a tad easier. You make a decision. But sine of 4 theta is, well, 4 theta is 2 times 2 theta. So double angle. Think about this as x. Sine of 2x is 2 sine x cosine x. Imagine this is x, everybody. Let's say this is x. So it's 2 sine x cosine x. This is x. Okay. 2 sine x cosine x. 2 sine 2 theta cosine 2 theta. Now, let me erase my work. This is 2 sine theta cosine theta. And cosine 2 theta, there are three different ways of writing them. We want to go with the sine, so 1 minus 2 sine squared. So obviously, if we multiply here, we get 4 sine theta cosine theta. So 4 sine theta cosine theta. We want to make it look like that. So let's separate the cosine theta, everybody. We want to make it look like that. We're going to separate the cosine theta. Now the 4 sine theta, if I distribute, I get 4 sine theta minus 8 sine cubed, and I get exactly what I was looking for. In this case, I can use the right-hand side. First thing first, I'm going to take out the common factor of 4 sine theta from the parentheses. If I take it out, so cosine remains 4 sine theta times 1 minus 2 sine squared. So I'm going to write these two as 4 sine theta cosine theta. I'm going to just change the order. If you look at these three pieces, the number 4, cosine and sine, I just rewrite them. And again, 2 sine theta cosine theta, this is 2 times 2, everybody. So 2 sine theta cosine theta, I'm going to separate it because 2 sine theta cosine theta is sine of 2 theta. So I'm going to replace this with sine of 2 theta, and I'm going to replace this with cosine of 2 theta. Again, let's assume this is x. So 2 sine x cosine x is sine of 2x, sine of 2x. So sine of 2 times 2 theta, which is sine of 4 theta. So which one is easier? You make a decision. I have no idea. Okay. Briefly, let's cover the product to sum and sum to product formula. We know the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Okay. So we're going to give them numbers. We're going to assume this equation 1, 2, 3, 4. This is equation 3, equation 4. So we're going to call these equations 3 and 4. Equation 4 minus equation 3. If we subtract the top from the bottom one, please understand it becomes cosine of alpha minus beta minus cosine of alpha plus beta. Then this one cancels this one, okay? And you get sine of alpha, sine of beta, minus, maybe I write this so it becomes clear. So what this means is cosine of alpha minus beta minus cosine of alpha plus beta equals cosine alpha cosine beta plus sine alpha sine beta minus, now we're going to subtract this, minus cosine alpha cosine beta, minus minus becomes plus sine alpha sine beta. And I hope you see that these two cancel each other. We get 2 of this. So what is sine of alpha sine of beta is the left-hand side divided by 2. So 2 sine alpha sine beta is cosine alpha minus beta minus cosine alpha plus beta. Therefore, if you divide it by 2, you get sine alpha sine beta is half of cosine alpha minus beta minus cosine alpha plus beta. This is the proof for this one, everybody. I'm going to erase my one. Now, let's add these two and divide it by 2. In other words, 1/2 of cosine of alpha plus beta and cosine of alpha minus beta, in any order you want to write it. If you add them up, these two cancel each other. Add them up, these two cancel each other. You have 2 of this, but you're going to divide by 2. So equation 4 plus equation 3 divided by 2. I hope you see that it gives you cosine alpha, cosine beta, 2 of them equals the sum of these two, and these two cancel each other. But you're going to divide by 2, that takes care of the business. cosine alpha cosine beta is half of cosine alpha minus beta plus cosine alpha plus beta. What about here? Let's look at equation 1. Equation 1 says sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. Equation 2 says the same thing with the negative sign. So if we add these two, okay, so that's, by the way, that's the proof of this one, everybody. Now, if we add equation 1 and 2, these two, and divide by 2, I hope you see these two cancel each other. If you add them up, these two cancel each other. So this plus this is equal to 2 of this, right? Divided by 2, you get one of them. So sine of alpha cosine beta is half of sine of alpha plus beta plus sine of alpha minus beta. And that's the proof of this last. This is known as product to sum. Now the sum to product is slightly different. Let's look at sine alpha plus sine beta is 2 sine alpha plus beta over 2, cosine alpha minus beta over 2. And let's look at the proof. To prove that, we are going to assume alpha plus beta divided by 2 is something like theta. Alpha minus beta over 2 is something else like gamma. You can go with x and y if it's easier, everybody. Some variable. And so having said that, the right-hand side is 2 sine theta cosine gamma. The right-hand side is 2 sine of alpha plus beta over 2, cosine of alpha minus beta over 2, and we're going to change it to theta and gamma. So that's 2 sine theta cosine gamma. So what is sine theta cosine gamma? What is sine alpha cosine beta? Is this one, right? We're going to use this one. So we have 2, we keep it, and this following that becomes 1/2 sine of alpha plus beta becomes theta plus gamma. Sine of alpha minus beta becomes sine of theta minus gamma. And clearly 2 and 1/2 cancel each other. So it becomes sine of theta plus gamma plus sine of theta minus gamma. Now replace the theta with alpha plus beta over 2 and gamma with alpha minus beta divided by 2. So we replace the theta, we replace the gamma. Since they have the same denominator, add them up. So I hope you see that beta and minus beta cancel each other. 2 alpha divided by 2 is alpha. In this case, alpha minus alpha cancel each other. Beta minus minus beta is plus. So you have 2 beta over 2 or beta. And believe it or not, that's sine of alpha plus sine beta. And that's the proof. So sine of alpha plus sine of beta. And so the sum to product sine of alpha plus sine of beta is 2 sine of alpha plus beta divided by 2 cosine of alpha minus beta divided by 2. And the rest of them follow in the same manner. You can prove them easily. Now, a simple example, use the product to sum formula to fill in the blanks in the identity. Sine of 14x cosine of 6x is half of something. Well, sine of alpha cosine beta is half of sine of alpha plus beta sine of alpha minus beta. So 14x and 6x, 20x, 14x minus 6x, 8x, and you put it in this format. And if you want to answer it as far as the homework or any assignment, just pay attention. They may ask you use the larger one here or there, okay? So you answer them accordingly. Express the sum to product, sine of 5 theta minus sine of 7 theta. And we're going to use this one. Sine of alpha minus sine of beta is 2 sine of alpha minus beta over 2 cosine of alpha plus beta divided by 2. So this will be 2 sine of 5 theta minus 7 theta over 2 cosine of 5 theta plus 7 theta over 2. Now this one is negative 2 theta divided by 2 is negative theta, and the other one is 12 theta divided by 2 is 6 theta. Now, sine of negative theta, we should know it's negative sine theta. So we get negative 2 sine theta cosine of 6 theta. Let me look at this example as well. Sine is 3 over 5, and theta is between pi over 2 and pi, which means it's in the second quadrant, and we want to find sine 2 theta and cosine 2 theta. First and foremost, sine theta is 2 sine theta cosine theta. This is cosine squared minus sine squared. We have sine, so we have to find the cosine. So this is 2 sine theta cosine theta. So cosine theta is plus minus the square root of 1 minus sine squared. A plus minus the square root of 1 minus 3 over 5 quantity squared. I hope you realize this as 9 over 25. 1 would be 25 over 25. 16 over 25 comes out as plus minus 4 over 5. Which one do we use? The second one, negative. Why is that? Because in the second quadrant, cosine is negative. So now you plug in 2 times 3 over 5 times negative 4 over 5. So the denominator is 25, the numerator is 6, 4, 24, minus 24 over 25. Cosine. Well, you can use actually any of those formulas. You can use cosine squared minus sine squared, 1 minus 2 sine squared. In other words, if you were asked to do this one, you could go with 1 minus 2 sine squared without having to go find that. But in this case, it makes, or 2 cosine squared minus 1. It makes no difference. We already have the cosine. So with that being the case, we use one of those formulas. Cosine squared is negative 4 over 5 squared minus sine squared is 3 over 5 squared. This is positive 16 over 25. This is positive 9 over 25. Subtract 9 over 25. From it, you get 7 over 25 as the final answer.